Hey guys, today we are going to talk about sigma notation. This is called sigma notation because it's got the Greek letter sigma here. Anytime you see the sigma symbol, that means summation in math. Right there is the starting end value. There is the ending end value. And this is an expression for a sequence. So what all that means is we are going to find the sum of terms 3 through 5 for this sequence. So that means 2 to the third power minus 3 plus 2 to the fourth power minus 4 plus 2 to the fifth power minus 5. 2 to the third is 8, minus 3 is 5. 2 to the fourth is 16, minus 4 is 12. And 2 to the fifth power is 32, minus 5 is 27. And I've actually already got that on my calculator. 5 plus 12 plus 27 equals 44. So we have a sum for those three terms of 44. Number 2 is the sum of terms 4 through 7. So 3 times 4 plus 1 plus 3 times 5 plus 1 plus 3 times 6 plus 1 plus 3 times 7 plus 1. So that's 12 plus 1, 15 plus 1, 18 plus 1, and 21 plus 1. And that all adds up to 70. Number 3, we have terms 1 through infinity for this sequence. Now that can only possibly be done if there is a common ratio that is between -1 and 1. So the first thing we need to do is find out what that common ratio is. Okay, so we'll find the first three terms so we can find out if there's a common ratio and what that ratio is. So 3 times 1/2 to the n minus 1, so 1 minus 1. 3 times 1/2 to the 2 minus 1. And 3 times 1/2 to the 3 minus 1. Okay, so 3 times 1/2 to the first power. 3 times 1/2 raised to the 1 minus 1 is actually the 0 power. So that's 3. Anything to the 0 power is 1 times 3 is 3. 3 times 1/2 to the 2 minus 1. So 3 times 1/2 to the first power is 1.5. So that's 3 halves. And then 3 times 1/2 to the second power. 0.75, 3/4. Okay, so we need to find out if there is a common ratio there. So 3/2 divided by 3. And that's 3/1, so the outer loop is 3. The inner loop is 6. So 1/2. And then 3/4 divided by 3 halves. Outer loop is 6, Inner loop is 12, which is also 1/2. So there is a common ratio of 1/2. Okay, and since there is a common ratio of 1/2, I'm going to break off my work here. I'll state that that means the absolute value of the common ratio is less than 1, so we can find the sum of this infinite series. So S sub n equals term 1, which is 3, over 1 minus r, which is 1 minus 1/2. So that's 3 over 1/2. Outer loop is 6. Inner loop, 3 times 1 is 1. So we get a summation of that infinite series of 6. Number 4. Again, we need to find the first few terms. So that's 2 times 1/3 to the n power. 2 times 1/3 to the first power. 2 times 1/3 to the second power. 2 times 1/3 to the third power. So that's 2/3 for the first term. Two ninths for the second term. And 2/27 for the third term. Okay, so it looks like on the top, nothing's changing, so we're multiplying by 1. On the bottom, we're multiplying by 3, so we've got a common ratio of 1/3. So that means the absolute value of r is less than 1, so once again, we can find the sum of this infinite series. So the sum of the series is the first term over 1 minus r. So that's 2/3 over 1 minus 1/3 is 2/3. 2/3 over 2/3 is 1. So we're going to have a sum of 1. Okay, on the next page, we are taking a sequence and writing it in sigma notation. So the first thing we need to do is find an expression for the sequence. So this one looks like it's going up by 5 each time, so we have a common difference of 5. So to write an expression, a sub n equals the first term plus the common difference times n minus 1. So that's 6 plus 5n minus 5, which is 5n plus 1. Okay, so in sigma notation, our expression is 5n plus 1. We have to assume this is term 1, and then we've got term 1, 2, 3, 4, and 5. So n equals 1 through 5. Looks like this time we're multiplying by 2, so r is 2. So a sub n equals the first term times the common ratio to the n minus 1 power. And that cannot be simplified, so we've got 5 times 2 to the n minus 1 is our expression. Starting with term 1, we've got term 1, 2, 3, and 4. Next one, it looks like we've got a common ratio of 1. It's not really changing anything up there, but on the bottom we don't have a common ratio. It looks like we have a common difference. of 2. So it looks like the top is always just going to equal 2, and on the bottom, we've got a common difference of 2. So a sub n is going to be 2 over, then we'll use our first term, plus the common difference times n minus 1. So we need to simplify that denominator. So that's 3 plus 2n minus 2, which is 2n plus 1. So our expression is 2 over 2n plus 1. Starting with term number 1, but we've also got to find out, because I've got a dot, dot, dot here, there's a gap. I've got to find out what term number this is. So this is n equals 1. This one, n equals, really don't know what. So I'm just going to put a box around this to separate it, but I know I've got to fill in that one spot. So to find the last term, remember in the denominator we've got 2n plus 1, and that comes out to 39. So 39 equals 2n plus 1. I've got to figure out what that n is. So I can subtract that 1, 38 equals 2n, and divide n equals 19. So I've got terms 1 through 19. Number 4. Looks like we're multiplying by 3. R is 3. So a sub n equals the first term times r to the n minus 1 power. So I've got n equals 1. I don't know what that last n is. My expression is 10 times 3 to the n minus 1 power. So to find out n, my last term has a value of 810. And I'll set that equal to the expression, 10 times 3 to the n minus 1. I can divide both sides by 10. I get 81 equals 3 to the n minus 1 power. From there, I'm kind of stuck unless I go to log form. The base is 3. The argument is 81. The exponent is n minus 1. And if I do log of the argument over log of the base, log 81 over log 3, and then add that 1, I'll find n. So log 81 divided by log 3 is 4, plus 1 is 5. So the ending n value is 5. Okay, so on number 5, it looks like we're going down 3 every time. Common difference of negative 3. So a sub n equals the first term plus the common difference times n minus 1. So it's 15 plus negative 3n, so I'll go minus 3n. And then plus 3. So negative 3n plus 18. Starting with n equals 1, and I've got a gap again, so I don't know what that last n is. So I'll do my work over here this time. The last term has a value of 0, and that equals the expression negative 3n plus 18. Subtract 18. and divide by 3. So n is 6. So this is term 1, this is term 6. So n equals 1 through 6. And last, number 6, it looks like in the numerator we are adding 2. So on top, I've got a difference of 2, and on the bottom we're multiplying by 5. So on bottom, r equals 5. So I'm going to have 2 separate expressions again. So on top, I've got first term plus the common difference times n minus 1. And on bottom, I've got the first term times the common ratio to the n minus 1 power. So I can simplify the numerator, so that's 2 plus 2n minus 2, which simplifies to 2n. So I've got 2n over 5 times 5 to the n minus 1 power. So n equals 1, and since there's a dot, dot, dot at the end, it's actually going through term infinity. And that's an expression of 2n over 5 times 5 to the n minus 1 power.